Hi everyone. Good evening. Good evening, Sunil. Good evening to our audience. Welcome back to our fifth and last session on quantitative trading webinar program. So as part of this series, this is the fifth session that we're gonna undertake today. And as part of this program, we have previously covered in the first session a general introduction about the industry. We then covered the introduction to the trading idea in our second session. The third and fourth session were dedicated to backtesting, where we covered a lot of popular libraries like Backtrader and also how we can build in-house backtesting function. We also saw in our last session why doesn't the backtesting strategy performance does not adhere to the live strategy performance. There are some gaps between the two. So typically, what are the pitfalls of backtesting? We covered in that. So I hope all those sessions were very useful and insightful to our audience. Let us know your feedback after this session as well. So this is the last session where we'll cover about the artificial intelligence and machine-based techniques, which you can probably use in quant trading. So once again, a warm welcome to Sunil and warm welcome to our audience. So over to you, Sunil. Nice to have you back.
Thanks, Salil. Thanks for the nice recap, and welcome audience again for the last session of this quantitative trading webinar series. So in this session, we will be focusing on role of AI in trading and investment. We will be discussing the various use cases which we have. Primarily, there are three use cases which we can have in about artificial intelligence in trading and investment. That can be categorized as sentiment analysis of news, Twitter, social media, posts using NLP. NLP is natural language processing. And third, another ways could be that we can do the prediction of some kind, some sort of, like we can predict the price movement of some instrument, and we can predict the trend of some instrument. Other way is the classification of data. So let us go all of them one by one. First, about sentiment analysis of news, Twitter, and social media. So it actually we need to see whether any news or Twitter by some influential person can impact the price of any instrument or not. For that, we need to do some sentiment analysis that gives three kind of parameters. On the basis of that, we can decide whether we need to buy or sell the particular instrument. So these three parameters are sentiment score of the overall news or Twitter or whatever statement which we are analyzing, entities, and category wise. We can category wise relevance score. Let us see how we'll take one live example for this. So this I have opened Google Cloud Sentiment Analysis. This is the API of that. I just entered one statement here. Apple launched its new version of iPhone in the market. So this is one statement. Let us say this came as the Twitter tweet from Apple. So if we analyze this, then it can be categorized as multiple entities. Apple is one of the entity. Version is one of the entity. Market and my iPhone are also the entities. It has also categorized this into various entity types, like Apple is organization, version, and iPhone is a consumer good. So if we see the sentiment of this, so it has categorized for each entity, it has categorized into various sentiments. So for Apple, sentiment score is 0.5. Score is 0.2 and magnitude is 0.5. Similarly, for iPhone, score and magnitude both are 0.1. For market, it is something different. And if we talk about the categories, it couldn't identify the categories here. But on the basis of categories, we can decide that this particular statement is falling in which particular sector, and in which particular sector or instrument or company we can buy or take buy or sell positions. So we'll not get too much into the detail of this. We'll move on to the other one. So this I just wanted to give the gist of that what sentiment score is and how it can be analyzed, and on the basis of that, how we can do the buy and sell orders. Next
So,
step is
Sunil, sorry to intervene here. So, if I understand correctly, this natural language processing is somehow you're trying to scout the internet or some sort of web scraping where you identify the keywords. Let's say Apple introduced an iPhone, and after I didn't do those keywords and identifiers, you're generating some sort of a sentiment score and categorizing into positive and negatives and using that as a data for your trading.
absolutely. We don't need to exactly web scrap the statements. There are APIs are available for Twitter, Facebook, and so on, and for Google also, for Google News also, which we can use to take the data in the runtime, and we can analyze that using the that sentiment analysis API from various vendors. Like sentiment analysis API is available from Google, Amazon, IBM, and there's so many other APIs are available which we can use to analyze the sentiment score.
Got it. Yeah, thanks.
So this is one way. Another way is to do the prediction of price movement, or do the prediction of the trend of the market. So like if we talk about price movement is nothing but, let us say you want to check what is the next close price, what is the close price of the next candle. On the basis of that, you can decide whether you need to buy or sell the instrument or not. So we'll come back to this again next. And trend is also very similar. When you want to see whether the market will go up in next few candles, or will go in the night down in next few candles. So this is what we can do using prediction. If we talk about classification of data, so classification is data is actually we are categorizing the things into multiple categories. Like if you want to see the next few candles will be period of next few candles will be trending or range bound. This information can be used to decide the strategy which you want to plan on. Let us say the next some period is going to be trending, then you can apply some momentum strategy. And let us say it is going to be range bound, then you can apply some mean reversion strategy. Accordingly, so this information can be used like that. Another way of classification of data could be, you can classify or categorize that what are the companies which are going to perform better in this quarterly result, which will be, and what are the companies which will not perform, which will perform worst as compared to the previous quarter. So like on the basis of that, again, you can buy or sell the companies or stock and take the trade. So, but in this particular session, because this is just 1 hour session we are planning to have, so we'll not be able to cover all different kind of use cases. We'll be focusing only on the prediction part as of now. So let us go into the detail of prediction. So first thing we need to, when we need to do the prediction, we need to develop a prediction model first. So let us see what are the steps involved in developing the prediction model. First thing, you need to identify what exactly you want to predict. And in the nomenclature of the machine learning and AI, we call it a target variable. So we need to identify what exactly you want to predict and what is the target variable. And for predicting the target variable, you need to have some predictor variable in place. I mean, what are the variables on the basis of that you will predict the target variable. For example, if you want to predict tomorrow's close price, then you may need to have today's close price and yesterday's close price and last 10 days of close price to see what is the pattern. On the basis of that, you will be try to predict the tomorrow's close price. So in that case, 10 days of close price can be the predictor variables. And after that, you need to see, depending upon the data which you want to predict and predictor variables, you need to gather the data. So you need to have the close price of last 10 days. But you need to have, if you want to train the data, then you need to have the predictor data for a little longer period, or maybe less last few years. So we need to gather the data accordingly. Next thing is we need to pre-process the data. So to make the machine learning model understand, we just cannot pass the close price to make the model, to understand it, to properly understand machine learning model. So we need to do some pre-processing by which it will be in all the data will be in the same page, in the same line, so that machine learning model will be able to make more sense out of it. Once we pre-process the data, we need to divide the data set into three parts: train, test, and validate. So train part will take care of the development of the model. Test will do the validation part, and validate will do by ourselves. That what on the basis of validation, how much accuracy we are getting out of the machine learning model. So
So
once
Sunil,
yeah,
one question here. So whatever data we have gathered, we are converting into some specific format for the machine learning model to understand. That is what we call the pre-processing stage, right?
right,
Further, when we divide the data set into these three subcategories, when you say we will train the data, uh, do we mean that we will store a portion of the data? Let's say if we have 10 years of data, we will store some 8 years of data as the trained data set, which will basically teach our model the specificities of the data set. Let's say if Nifty goes up, then usually we find that Maruti or the large cap stocks go up. That sort of a learning is basically why we are making training data set. And the remaining 2 years of data set, what we call as the test data set, is what we will check our machine learning model on, that whether it is giving the correct output or not. Is my understanding correct? Or
yeah, I will just add a little more into it. Let us say we have 10 years of data. So we can say 1 year of last 1 year of data I will go for the manual validation. And out of 9 years of data, 80% of data will go into train, and 20% of data will randomly go into the test. So 9 years of data will be divided into two parts: train and test. That will be random parts will be, so machine learning model will take care of the test and train both of it. So we will not play much role into it. We'll just say that how much percentage of data will be test data set will go in the tested data set, and how much will go in the trained data set. And most of the time we define that test data set will be selected randomly, so that we will be able to get to know the accuracy will be divided across the data set and across the period.
got it, got it. So when we download the data, अगर मैंने Yahoo Finance से 10 साल का डेटा उठाया, तो मशीन लर्निंग मॉडल को मैं ये डेटा प्री प्रोसेस करके दे दूंगा एंड जस्ट स्पेसिफाइंग द रेशियो कि 80-20 स्प्लिट कर ले वो, एंड इट विल ऑटोमेटिकली populate the test data set and the training data set. I don't have to manually populate that feature.
Yeah. By default, it
Okay.
actually converts the test data set into randomly selection data itself. It doesn't do like that last 1 year will go in the test and first 8 years will go in the train. It doesn't do like that. That it's
Got it.
randomly. By default, it is like that.
Understood. Yeah, thanks for that explanation, Sunil.
So once we reach to this stage that we have divided the data into three data sets and pre-processed the data into the required format, and we have defined the target and predictor variables, then it comes to the AutoML part. We will be focusing about AutoML in this session, so that the audience doesn't need to worry too much about the modeling part of it. So actually, machine learning itself is a big the whole subject. It's a big subject. I don't want to. It is not possible for us to cover in the 1 hour session. So we'll be focusing only on the AutoML, so that the audience will be able to understand the flow and the structure of the machine learning model. That how we can develop the model and how we can do the prediction. So we'll not go into the detail of each and every model which we'll be using here. So in AutoML, what happens is it automatically, there are few libraries which are used in the AutoML context. Like H2O is one of the AutoScaling is there. H2O is there, and so many other libraries. We will be focusing only on one library, that is H2O. So in this AutoML function, what it does is it uses multiple ML models with the predictors which we have defined here in the previous step. It trains all the data using those predictors, and it does the automatically feature engineering of all the predictors as per the model it is going to train. After that, it ranks all the models one by one as per their performance. As per the ranking, it selects the best model out of it and save that in the file. This is what the AutoML process does. So this includes several steps which you need to write the code for it. We'll come into this in detail when we reach to the coding part of it. So once it is done, our development of prediction model part is complete. Now we are all set to do the prediction. For prediction, again, we need to gather the data set for the prediction. As we know, our predictive variable is target variable, name is target variable. For that, we need to have predictor variable in the place. And another thing is we need to have the model in the place. So we'll import the model from the file which we have stored here. Like in the last stage, we have saved that model in the file, the best model. We'll import the same model from the file, and we'll gather the required data set. We'll pass on the data set with predictors to the model, and that's all. We will be able to predict the target variable. So if it is not so clear, don't worry. Because we will be doing the practical in very soon in next few minutes. Before that, I'll just tell you what are the if you have to write the code, how we have to write the code for this. So we'll create a class. Let us say we will be predicting the direction of the stock. So we will be creating the class here. So in this example, what we will be doing is we will take one particular stock or any instrument like Nifty 50, and we will be predicting the close percentage change of the next day for Nifty 50. This is what we will be planning to do. So these are the various functions which will be required to declare during this inside the class. One is init function. In this, we'll declare that which particular script or instrument we are planning to predict, and what is the target variable. In this particular case, we will be using the close percentage change as the target variable. After that, the other function will be data preprocessing. We will be download the data. We'll initiate the market data variable like close percentage change, high percentage change, and so on. And we will properly declare what are the predictors and what are the target variables. And I'm skipping this function as of now. We'll discuss it again once we take a look at the function, take a look at the program. Next function will be train AutoML. This will take care of that AutoML part, training of the AutoML part. In this function, it will use multiple ML models with the predictors, which we have defined here. See, the output of this function is data frame X and Y. X and Y are the predictors and target variables. We'll take the output of this function as the input in the train AutoML function. So as you can see, all the output are input here. So in this, it will use multiple ML models with the predictors. It will do the feature engineering by assigning weights to the predictors automatically. We don't need to do anything in that. It will see which model which we are using and which predictor is there. Accordingly, it will assign the weights in this. And again, it will rank the model as per the performance. As you see that it is almost the same steps which we have discussed in the previous slide. It will select the best model and it will save the model in the file. And that's all. The development part of the model is done. And next function is validate. That is nothing but for prediction of the, we will be predicting the target variable using the model which we have saved here. So it will import the model from the file which we have saved here, pass the data with the predictors, and predict the target variables. Now we will see the practical approach of this. We'll see the code now. Any questions so far, Salil?
No, none from my side, Sunil. So just to reiterate, we have developed two separate models in script, which you just showed. One is the XGBoost and the second is the AutoML. So both of these, yeah. So the train XG is a specific model which we call XGBoost, and the AutoML is another model which basically has a multiple machine learning models housed within it, and it selects the best model as per the data which we have provided to it, pops that model, saves it, and then uses that particular to validate your data set, right?
Yeah, absolutely right, Salil. The train XG is the one which we are planning to discuss later. So as you have rightly mentioned that this will cater of only one model as of now. Let us say we have decided one model called XGBoost. This is one machine learning model, and which is based on the decision tree. So in this way, we thought that XGBoost is the best model for the prediction of the target variable which I'm planning to do. So I have defined here XGBoost. In other ways, that train AutoML. Let us say I'm not too good in machine learning, and I don't know which is the best model for my for predicting the target variable of Nifty. In that case, I will leave everything on the AutoML part, AutoML function. Let the AutoML decide which is the best model for predicting the close percentage change. So we can do with both the ways. If I'm well versed and if I know the models very, very well, then I will go with the first approach. I mean, I will decide the model by myself. Otherwise, I will go with the AutoML approach.
Okay. Understood. Yeah, thanks, Anil.
Yeah. So we'll discuss about this XGBoost approach also. Let us see how AutoML works. So I will go into the detail of each function one by one little later. First, I will tell you the basic things. So in the init function, we are deciding that what are the script predicted. Here we will define that which instrument or script will be predicted. Next is the training date and prediction variable. Prediction variable is nothing but the target variable. Here we have defined as close percentage change n_1. That is the next day of close percentage change. And here we have defined is till what date we will be taking the training data set. And after that, the rest of the data will be considered as the validation data set. And here number of days of data required to train is 4,200 days I have defined here. Number of days of data required to predict initial predictors or validate is 400 days. Like this, I can define the basic variables in the init function itself. And let us see that what are the predictors I have defined. So after downloading the data, open, high, low, close for Nifty 50, I have converted them into a same range variables like open percentage change I have defined as open percentage change, close percentage change, high percentage change, low percentage change. And I have taken the previous days of data as all of them as P1. P1 is the previous day of data. P2 is the previous 2 days of data. So like that, I have taken 3 days of data to do the prediction of close percentage change n_1. So this is for next prediction of the next day of close price. So these are the various predictors I have defined here. Alongside, I have mentioned simple moving average also of last 12 days of period to as a predictor to predict the close percentage change of next day. And I also think that every weekday behaves differently, even though the input predictors are same. So that's why I have taken weekday also as one of the predictor to do the prediction of the next day. So weekday is also one of the predictor. So before we go into the detail of it, let us run the function and see how it works. So when I will run, it will just, I have passed the variable script as NSCI. So I will be taking data from Yahoo Finance. So NSCI is the script code for Nifty 50 in Yahoo Finance. So that's why I have kept an NSCI here. And I have mentioned here AutoML is equal to true. And I'm passing this in the train models function. So when I'm saying AutoML is equal to true, it will run the AutoML for, it will train the AutoML function. It will not do the specific model training like XGBoost. So let us run it and see how it goes. See, as you have seen.
Sunil, just sorry to intervene in between. So I'm seeing a couple of questions in the chat box. So people are asking if we have a certain playlist or link for all these sessions. So to answer that, yes, we do have, and we'll be sharing the playlist along with the proper chapters created for each session with all the ICICIdirect customers. So yeah, watch out for that. That's still being rolled out. Then there is one question with aspect of academic interest. He wants to know if there is any natural language for sentiment analysis, Google natural language for sentiment analysis, or any resource which is available for free or on a chargeable basis. So I'm guessing that, like Sunil, you showed us an example where you went to the IBM site and you tried to generate a sentiment score for a particular statement, iPhone launched by Apple. So are those resources available for free, or do they charge you for that?
I think those are not free. They charge it for that. But actually, those are the, if we use the API of those in the cloud environment of Google and Amazon or IBM, but if there are some open source code is also available for these things, I think that they don't charge for that. If you use the open source code, then and there's some more other libraries like Spacey, NLTK, and there are few more which we can use to do the sentiment analysis by ourselves. We don't need to use the API for that. We can create our own sentiment analysis functions.
Okay, that's nice to know. Can you just repeat those libraries?
NLTK is one of the very popular NLP library, and Spacey is another very popular library to do the sentiment analysis and NLP related functions and processing.
Got it. Then there is one question for AutoML as well. How do we import that? Is that a library of some sort, or what is that? How do we import these machine learning models into our script?
So, like, it is just like any other library. We can install the. As of now, we are using H2O as a AutoML library here. So we can, just like any other library, we can just say pip install H2O. It will install the library in your machine, and that's all.
Got it. Got it.
We'll go into the detail of the technical just after this. Let us see how the flow works. So like
Sure.
I just ran the functions. So the pre-processing part is done, and like this parse progress with this statement, the pre-processing is complete. Now AutoML is in progress. So if we go back to the slide now, as we have discussed, first init functions get processed, after the data pre-processing, and after the train AutoML. So data pre-processing is done. Now train AutoML is going on. As you can see, it is in the progress bar, it is saying AutoML is in progress. So meanwhile, let us see, as we have seen, what are the predictor variables which we have defined here, list of predictor variables. Let us see the pre-processing function by the time the processing of AutoML will complete. So this is the data pre-processing function. As you can see here, we are defining the data pre-processing function will be used for two times. One is for training the data set, another is for prediction, both the times. And both the times we need to download the historical data. So here we are downloading the historical data using Yahoo Finance, like yf.download instrument name, and we are giving the period here. Once the data is downloaded, we are converting this into local time zone, and after that we are using the process nifty d function, which we have just seen, where we're declaring all the market data predictors and the indicator predictors. So this will give us the data set for the indicators and the market data predictors, and that's all our work is done. After that, we are just dropping NA rows from here. And if there is any null value is there, then still some null value is there in between, then we are performing forward fill also, just to make sure that nothing goes wrong. Because if there is for NA rows, some of the AutoML libraries doesn't support NA predictors or target variables. So we need to either fill or we need to drop them. After that, we are declaring y is equal to predictor variables, which we have initialized in the init function. We are just initializing the y, and x is the list of predictor variables. And after that, we are converting the data frame into H2O frame data frame. That is the normal convention of H2O data frame, that H2O reads only the H2O converted data frame only. So we have converted data frame into H2O DF. So our result also have come by now. So if we see, the accuracy is coming to 0.51%, that is 51% accuracy, and returns we are getting as 4%. It means whenever the model is saying the market will go up, the close percentage change will be in positive if we take the buy position at that time, and whenever it says the reverse, then it will go in the negative, then we will take the sell position. In that case, our returns will be 4%, 4.1155% for the test data set. And let us say what exactly it has done during that time. There are some more parameters of the accuracy, which is MSE, RMSE, MAE. We will not get into too detail of it. We will just say this is the mean absolute error, which we can define. Mean what we want to predict, and what is predicted and what is the actual value. It is a difference between the two of them. And here we are defining accuracy is, let us say we are saying close percentage change will be in positive, and actual price will also will go in, actual change was also in the positive. Then we'll say the prediction was accurate. So this is our own defined parameter of the accuracy, and the vice versa. I mean, if it is saying it will go in the one negative, and it actually went to the negative, irrespective of the change in the close price, then we will say the price was accurate, the prediction was accurate, otherwise no. If we go a little up, you can see it has, this is the final function it has created, stacked ensemble best of family AutoML model. It has defined as the best model to do the prediction. So let us see where it is stored. So we have it automatically stored the details of that model, which is the best model in this particular file. Here it defined the timestamp. You can see the timestamp is 432. It has mentioned the name of the script or the instrument which we are planning to predict. It has defined the path and as well as the name of the model, which is the best model selected by the AutoML. It mentioned the accuracy and the returns and so on. So now the development of the AutoML part is done. I'll go back to the code now. So I will just close the program as of now. So this particular session of the console I have closed. I restarted it. So now let us say if we have to do the prediction. Now what it will do? It will do the data processing again, like it has done before. And after that, it will take the model from read the file which we have just opened, take the detail from there, import the model, and after that, do the prediction. So what I will
Sunil, sorry. But just to recap, what we are sort of trying to do here, we have generated a data frame where we are putting in the predictor variables like the previous closing percentage change, the weekday, so and so forth. And we are pre-processing that data frame and then sending it to our AutoML model. The accuracy, the error for which we just saw in the console box. It then saves that AutoML model in your system. And then when you want to validate, or let's say you want to predict the price of Nifty, you tell your model where that model is saved. It will pick that up from your system. And then using the same predictive variables, it will try to give the output of the target variables.
Absolutely, you got it absolutely right, Salil. This is what exactly it will do now. Now the data, the reference of that model is stored in that file which we have just seen. So, and when we will do that prediction part, so I will just comment the train model part as of now, and I will just run the predict model function and see what exactly it does. So we have already in the init function, we have already defined that how many days of prediction it will do. It was mentioned 400 days of prediction. So, and it will take the same model to do the prediction. So I will just run it. It has completed the run. So it has taken the data from 1st January 2021, or it seems it has taken the data from 2nd Feb, depending upon which data which we asked to select. Maybe because it must have removed some of the rows because of NA also. So now if we have used the same approach, whenever it said that the market will go up, then we'll buy. Otherwise, if says the market will go down, then we'll sell. If we go with that trading approach, how much return we could generate? It is saying we could have generated 4% return, even though the accuracy was only 48%. So the graph will look like this, like the blue line. On the other hand, let us say if we say we'll take the position in the stock only if the percentage change prediction in the percentage change is more than 0.25%. If it is less than 0.25%, we will not take the position. In that case, accuracy is 55%, little more than that. And the percentage returns also increase to 8.4%. In that case, the return graph during this period looks like this, the orange line. So it looks little better. So it seems there is we are omitting the chances of error using that filter. If it is less than 0.25%, the percentage change, we are neglecting it, considering there could be error in the model this much. Even if it is more than that, then only we consider that to take that trade. Because of that, the accuracy has increased and returns also increased. Any questions still here, Salil?
No. So I'm just trying to wrap my head around why we are using this filter of 0.25%. Is that because if the model says that the change in price of Nifty is, let's say, 0.1%, it's still so close to the borderline of positive and negative that it's safe to assume that only when the model gives you a return above a certain threshold, what we are calling 0.25, then only we are allowing the prediction to happen. Otherwise, it can fall to the either side of green and red. I mean, अगर वो 0.1% हमको रिटर्न देता है तो चांसेस हैं कि अगर थोड़ा सा भी एरर हुआ तो वो नेगेटिव रिटर्न का प्रेडिक्शन भी दे सकता है, and that will be detrimental to our strategy.
You are absolutely right, Salil. To understand it a little more better, what we can do, we can take the data we can try to visualize the data a little more better. So I will take whatever the output data which we have got from the prediction. I will put that in the tableau and see that how we can understand what we are discussing. How if the percentage change is low, then how it can lead to the error part of it. So I'm just creating one more instance of Tableau. So I have just taken the data from prediction data. So these are the various instances where the returns went up and down. So wherever you can see, wherever the returns are down, it means the prediction was wrong during that time. And we have taken the absolute percentage change as the weight here. So this is the percentage weight is nothing but the percentage change for the prediction, but we have taken the absolute value of it. So let us say we will take percentage change whenever it predicted less than 0.5%. We do like this. I will take the cumulative sum of the returns here. So the returns are coming to around 18%. If I take all the values starting from 0, then the returns are almost 4%. And in between, there was a drawdown also. So to reduce the chances of error, I will just take it to, let us say, 0.1%. So whenever I'm omitting the prediction, I'm neglecting the prediction whenever the percentage change was less than 0.1%, then after that the results got improved a lot. Let us say I neglect or remove the prediction to 0.116%, then it is 6%. Let us say we make it 0.2%. Now the accuracy has improved a lot. There are very few cases when we are wrong. Like that, I can keep checking. By visualization, we can understand which is the best model, best way, till what time we can remove that. We can neglect the prediction and will not take the trade during that time. So this is one way of understanding that. I'll just remove the calculation part. So here, if you can see, the number of instances are less, but accuracy are also improved. There are very few cases when we are wrong in the prediction. If we take the trades only when the percentage changes more than 0.25%. Okay, coming back to the code now. So we have seen that how AutoML works and how prediction works. Let us see the code and inside that. We have already seen the code for pre-processing and defining the predictor variables. Now let us see the code for AutoML. First of all, let us see what exactly we need to declare. Here we need to declare S2O. S2O is the name of the library. We need to import S2O AutoML function here to do the AutoML part of it. And for XGBoost, we need to specifically, we need to import S2O XGBoost estimator. But we will be not discussing it as of now, because we will focus first on the AutoML, then we'll come to the XGBoost function of it. Now let us see what we are doing within train AutoML function. As you can see in the data preprocessing function, the output was HODF, X and Y, and data frame. So we will be using this as the input in the train AutoML function. So as you can see, predictors we have defined as X. X is nothing but the list of predictors which we have created there. Response is the target variable, that is Y. Here we are splitting the dataset into two parts, train and test, into 0.8, mean 80 to 20 ratio. After that, we are calling S2O AutoML function, and we are specifying that don't use more than 20 models to train and do the analysis of selecting the best model. After that, this function will take care of the training part. It will train all the 20 different models using the predictors and target variables and using the training frame as train. After that, out of this, it will create a leaderboard. Leaderboard, it will list down all the models in its as per their performance, and it will take out the best model using AML.leader. This function will give the best model, the top performing model out of the 20 models. Once we are done with this, we have stored the best model using this function download underscore mozo. This is the function of S2O library by which we can store the model in the file format. So we have stored it there. And just to make sure the file is properly stored, we have uploaded it again here to see that it is working fine. First, we have downloaded into file, and after that we uploaded the same file again to verification. Now we are predicting the test dataset using the best model. So you can see best model dot predict. We are passing the test dataset here, and after that we are checking the various accuracy parameter, and we are checking how much returns which we have got in test dataset and how much accuracy it has. Any questions by now, Salil?
No, Sunny. No. I guess this is quite similar to the model XGBoost, which we already tried. So the basic functioning of the model remains the same, just a small changes in few details.
Yeah, we can see the XGBoost also now. If you see, it is almost similar to the AutoML function. The only difference is we have defined only one model. The name of the model is XGBoost, and we are training only one model instead of multiple models and taking out the best out of it.
Got it. Got it. Yeah.
So that will take care of the this AutoML part of the machine learning library prediction part of it. So if any question, we can take it up. Otherwise, we can wrap up the session here.
Yeah, sure. Let me just check if we have any more questions in the chat box. So again, a few of our audience participants are asking if we have a created playlist for these sessions. Yes, we do have, and we'll be sharing the same with you guys over mail, SMS, and notifications. So yeah, that will be taken care of. Also, just to add on at this point, that all these scripts which Sunil has walked us through, it might be it's very likely that you won't be able to follow the complete script over a YouTube video. So we'll give you access to it over a GitHub repo so that you can access these, play around the code, and see for yourself what changes can you make, how can you improve the accuracy. But as a precursor to all this exercise, which might seem a bit complex at the very start, just try to get a hands-on experience on all the free resources that are already available, be it be Spider, Jupyter, these IDEs where you can run your scripts. Also Tableau, which is a very popular charting platform. We saw that in our second session. We also saw it today when we tried to optimize the weights or the threshold of returns so that the accuracy can be improved. So getting a hands-on experience on these softwares for yourself will actually, expedite the learning wheel for you guys. So yeah, just wanted to add on to that, and I guess that is most of the questions that there in the chat box. So Sunil, I guess that wraps up this excellent webinar program that we have conducted over a course of, I guess, 6 weeks now.
Yeah.
So yeah, I hope that the audience found it very insightful, very enriching. I personally found it a very amazing experience because it's really tough to find the proper resources and the proper mentor if somebody wants to take the jump in algo trading or quantitative techniques, because not there aren't very many resources which teach you how to do this. So yeah, once again, a very heartfelt thanks to Sunil and to our audience who has joined in for all these sessions. So I hope that for all those who have watched all the 5 sessions, we have improved or helped you expedite your journey in the field of quantitative trading. Yes, Sunil, over to you.
Yeah, thanks, Salil. And it was a wonderful journey for me as well. From last 6 weeks, I used to wait every week for Friday for this webinar. So yeah, it was quite a journey for me. And so I would like to say thanks to you and all the audience for spending their time for the webinar and contributing there in the comment box. So like Salil before also said, we seek your comments and feedback through the feedback section or the comment section there. Or you can send us the email also.
Absolutely, absolutely. This is your feedback. ICICI will try to engage you in more such insightful sessions in the future. So please do that. And thanks for joining in, guys. Thank you once again, Sunil, for a very wonderful webinar. Yeah. Enjoy your evening, guys.